Welcome back. In this episode, we're gonna take a look, as promised in the last episode, at RabbitMQ and Celery within our Kubernetes Django deployment. So basically, I have it open already. What do we need? We need a RabbitMQ with RabbitMQ 3.7 Alpine, and we need a Celery worker, that's what it's called in here, where we basically just use the Python image, but use this as the command. And actually the nice thing is the Celery worker doesn't need to have any ports exposed, so that's a very simple deployment actually. We could just use a pod. I'm gonna keep using deployments for the sake of it. And the next thing is RabbitMQ. We don't have a volume in here actually. We don't have secrets in here either. We're just gonna go for like a less secure way, to be fair, where we don't need to define any credentials, but it also speeds up the whole process. So if you have the graphic in mind that we had before, basically we're scratching the RabbitMQ secret and the RabbitMQ volume, and in the end we just use the RabbitMQ hostname to access it. We don't need any security at this point, which is something you can consider, but you can also just go for a fully blown security setup. But with RabbitMQ, RabbitMQ for me is not something where you have any sensitive data stored. Of course, there could be something stored that's sensitive, but in the end, there should only be like a primary key or a hint like, hey, send that user a welcome mail or a reminder mail or whatever. And that means you have a user ID stored and maybe a date or something like that. And so it's not sensitive. At the same time, I believe RabbitMQ, you should see RabbitMQ as something where data can get lost. You can configure RabbitMQ to store data on your disk, that's fine. So if in case RabbitMQ crashes or you need to restart it, data stays on the disk, but we don't have that use case right now. All right. So what need we to do first is we need to have a RabbitMQ deployment. So I'm gonna create a new file in here. I'm gonna call it rabbitmq.yaml in the same format that we have everything else. And I've prepared that YAML file already, so I'm gonna go step by step. We need a deployment, obviously, and it's gonna be named RabbitMQ. In the spec, we wanna have replicas equals to 1, and we are going to say selector, like that bullshit that you need to define. Yeah, it's just some selectors and some templates. Yeah, fine. And now the interesting point for Kubernetes is the spec, where we define our containers. Within that containers, we're going to define our RabbitMQ container, and we're going to define the image. And the image we're going to use is going to be the same as in a Docker Compose YAML. It's going to be RabbitMQ 3.7 Alpine. And we're going to open a port. I've actually looked it up before. It's port 5672. For RabbitMQ. There's other ports if you want to do some other fancy things with RabbitMQ. If you want to link them together, there is other ways to do that. Feel free to look that up. It's not part of this tutorial, although. And last but not least, we could define environment variables, but as we don't have any defined in our Docker Compose YAML, we are not going to define any environment variables here. All right, so the RabbitMQ setup is like this, and it's basically the same as our Postgres setup. If you want to look at our Postgres setup, they are basically the same. I just replaced RabbitMQ, replaced Postgres with RabbitMQ and put in the right container port. And we don't have any environment variables. The only last thing we need to do is we need to have a service, and in that service we need to tell Kubernetes how is our service being exposed to other Kubernetes services or pods. And essentially we're going to replace Postgres with RabbitMQ again. And we're going to have to replace the port. All right. So with that being said, I believe we can do kubectl apply -f deploy RabbitMQ YAML Great, no syntax errors. And we should see a RabbitMQ container being spawned. And we can see a RabbitMQ service being available on cluster IP. So it's not exposed to the public, it's just internal. But that means, depending on our settings, I think our settings says that we have RabbitMQ linked. Yeah, our Celery broker is set to AMQP RabbitMQ. And within the cluster, within the same namespace, it's going to use that as the host name. So we actually don't even need to change the configuration of our Django project. It should work out of the box as Celery broker URL is set to the correct one. Is this running? Yeah, RabbitMQ is running. It's always good to check the log files for any problems that might have occurred. So let's open a new tab and say kubectl logs. And this one, and it's actually empty. I'm not sure if that is good or not, but hey, let's find out. So how do we find out? If you want to take a look back at the tutorial that we made, we basically said when the user signs up, we are gonna put a message to RabbitMQ that says send sign up mail and the user ID. Basically, if you want to take a look in the source code that we can quickly do, we have our authentication app, and there we have a task. The task is called send post sign up email. Basically, we don't send an email yet because I don't have an email server configured, but you could just use Django's send mail function here to send the mail. And it basically for now just prints a message, post sign up, user primary key equals user primary key. And you can use that, like this is the message. We just sent the message, and there's nothing sensitive in there except for the user primary key. So if that message gets lost, well, whatever, the user doesn't get a welcome mail, they can re-trigger that at some point. Okay, and that message is being triggered in our views py, I believe, in our post of the registration view. There we triggered a send post sign up mail. That's the post function here. And yeah, so if we sign up with foo@bar.com, then this should send a message to Celery. To RabbitMQ. It is, however, possible that this does not work. We need to investigate if it can connect to RabbitMQ or not. This is why we have our logs again. So I'm gonna double check the logs. And the logs here say nothing. What do the logs for this container say? Logs for this container say also nothing. But the connection was reset, so there definitely was a problem. Oh, there we go. We got a worker timeout. That's actually a unicorn. So it's quite possible that we haven't been able to reach the RabbitMQ service. All right, then let's debug. So how to debug this problem? We're gonna exec into one of the containers, start a bash, and the first thing I'm gonna do is ping RabbitMQ. Okay, so I'm not sure if it can actually be reached. I'm gonna just try to connect via telnet, RabbitMQ, and the port was 5672. 5672. Oh, I don't have telnet. Okay, then the next thing to try is Python manage py shell. All right. And we're just gonna actually do the same as we do here. We're gonna import the post sign up mail signal. There we go. Paste. And we're just gonna call the method that's being called below here and see if that causes any error message, because clearly there was a problem. Yeah, well, user is not defined. Let's add a 1 here. And so let me move that up a little bit. And it seems that it is lagging at this point. And I'm not sure why. Maybe the RabbitMQ container is, oh, it says it's up. That's interesting. I mean, it's the Django page itself is working. It's really just sending something to RabbitMQ that's not working. I'm wondering if this is the wrong port. Let me double check if I use the right image. Yep. It's also interesting that there is no log output. I'm just gonna double check the log output that we actually expect if we put the RabbitMQ up, because I believe there should be log output. I believe the RabbitMQ container hasn't started up properly. Yeah, I mean, I'm canceling this now. The send post sign up mail is clearly not working. I'm gonna exit this container. So in the background, you see this just finished here. There should be plenty of log output in our RabbitMQ when it starts up. It should even actually tell us, like, there's a cookie hash, like it generates a secret, but it doesn't do that in our case. For whatever reason, it doesn't do that. So I believe something might have been misplaced in here. So let's see what the deployment actually does. So the next step basically is to say kubectl edit deployment RabbitMQ, because this will tell us a little bit of information what is going on with the deployment. And I forgot again to set kube editor equals nano. There we go, that's better. So there we go. Can't see anything wrong here. I'll pause the video, let me figure that out off camera, and I'll be back in a second. And I'm back. I have basically digged deep and I found this issue with Minikube, and apparently there's an issue with a couple of different images that don't work on Minikube 1.5.0 that I was using. So I've downloaded Minikube 1.5.2 and stopped my Minikube server, installed the new version, and I'm starting up the server now. I'm actually curious to see whether this will keep my Kubernetes installation or my pods and my deployments intact, because that would be really epic. But I'm quite confident that they won't stay as they are, and it will probably just be overwritten, but we will see. And we will also see if that actually fixes the issue that we just had. So yeah, maybe I can tell you a little bit more about the debugging steps that I took. There's one more thing that I basically tried. I tried to use a different image of RabbitMQ. So I used RabbitMQ 3.7 Alpine, and I thought maybe it's Alpine related. So I used RabbitMQ 3.7 and that didn't work either. And then I took a look at some more log output and the events of Kubernetes, and nothing really told me anything that is going on, and basically you will find very similar messages in here. Like there's no log output, and some people digged a little bit deeper, and yeah, they found that it's something that they've changed and has something to do, I think, with the number of files open that you can have. But yeah, I didn't go that deep, to be fair. I left that to the professionals there. Anyway, I also took a look at different tutorials. They didn't say that I made anything wrong or something, so everyone basically points to the same thing. I've also restarted my IDE in the meantime, so there we go. Okay, Minikube is back up. Now I am interested to see what is going on. Oh, this is amazing. It actually kept my pods running. It kept my load balancer running. Really? My whole setup is still running? Wow, I'm amazed. This is not something that you would typically see, to be fair. But good job to the Minikube, guys. Anyway, let's take a look at this RabbitMQ container now. No logs. It's still having that problem. We are on Kubernetes 1.16.2, and we should be on Kubernetes 1.16.2. But I'm not sure if we're actually in the right Minikube version. Let's SSH into our Minikube VM. No, that's this. Welcome to Minikube. Where would I find the Minikube version that I have deployed within that container? Locally, it says I have Minikube 1.5.2. That should have fixed it. Well, maybe, you know what? I'm gonna just kill that pod again. Let it bring it back up. kubectl delete pod. Maybe still something stuck from the last deployment. I'm gonna debug into that one. So let's take a look at the log. Oh, there we go. It started up now. That's better. So maybe the container was the old container and there was something stuck in it. That's fine. So RabbitMQ is up now, and we should now pretty please be able to sign up with Fuba 2. And the sign up has completed. That means our RabbitMQ is working finally. All right, so we've got RabbitMQ ready, and we got our Django app ready. Last one we need is our Celery app. And for that, damn it, didn't want that. Oh, come on, IDE, don't leave me alone. There we go. For that, I'm actually gonna create a new subdirectory here. I'm gonna call it Celery. I'm just gonna call it Celery, that's fine. And I'm gonna copy my Python deployment, but I'm renaming it to celery.yaml, and we're gonna leave most of it the same. However, we don't need an ingress, that's fine. We need the database, we need Django settings, that's also all fine. The image will also be the same. We don't need a container port. And we're gonna rename the deployment to Celery. Actually, we're gonna rename it to tickets Celery. So ticket Celery, ticket Celery, ticket Celery. All right, that's fine. And there's one thing we can do now. We can actually specify a command in here between those braces there, and the command is gonna be the same that we're gonna use in a Docker Compose, which is Celery -a blah blah blah. And we are applying this command, or we're applying this one from our deploy folder, Celery YAML, and let's just hope for the best and maybe it works. It is now creating our Celery container. That's good. And the run gave an error. Maybe, I think I've seen that before. Maybe I need to use a different command up there. Doesn't give me any logs. I think you need to do it like this. Command is that, and I think the other things are arguments. I'm gonna double check that quickly. I think I had that open before. Kubernetes deployment container command. I had it open before. Yeah, you can see it here. So I think, all right, it's command, and then I need to separate the arguments with spaces. So let's quickly separate them and hope that this is enough. And once that is done, we should be fine. I'm applying that again, and let's see if the container is coming up. So the new container is being created. The old one has a crash loop back off, so Kubernetes will stop trying to spawn a container at some point. There we go. I think it got up. And we're gonna do kubectl logs -f. So it does say post signup user PK3. So it actually did receive a task. In case you don't believe it, let's just pin that to top and sign up again. Let's sign up foobar free. And we should see something popping up in the logs down there. There we go. Nice. All right, we got it running. So to summarize, we had some issues with Minikube and with Kubernetes in an old version, so I updated to Minikube 1.5.2. But we got it running RabbitMQ and we got it running Celery Worker. The next thing we want to do is to also get like a Celery management tool in there. Flower it's called, right? That's the name. So in the next video, we're going to install Flower in our cluster, so we get that as well. And I think we're going to do some polishing after that, see what we can optimize or what we don't need or what we did wrong, and maybe take a look again at all the files. As always, there's a link to the GitHub repository with all those files in the deploy subfolder in the video description down below. And see you next time.